I'd like to look at your in-class exercise number 18, the track race. This example is going to have you program the forces on this little red car so that it can run around this track. Okay, it's going to run around this oval track. I've already programmed in the AI. It's a rudimentary AI. It makes a lot of errors, but it's simple enough to travel around this track as long as you don't go too fast. If you go too fast, it's going to have some problems. So you're going to try to program in the forces on the car so it can actually go too fast, and you can see how badly I programmed the AI. So right now, this car doesn't do anything. When you get the program, it's going to look just like this. You're going to try to make it go, and nothing's going to happen. What we're going to want to do later on, however, is you're going to want to add in the forces on the car. You're going to do two types of forces. Right? One type of force is going to be the acceleration of the car due to the engine, and the second kind of force is going to be the friction of the wheels on the track. And so I'm going to have two different types of friction for you to worry about there. So you're going to have an anisotropic friction. That's going to make things fun, right? You like fun things. I think you like fun things. So the first type, right? The first type of force you're going to put on is just the thrust, basically, on the car. So the car is going to the car will have an impulse added every update time, right? Just the way we did it for the rocking. Only this time you're not going to control how fast it's going, how much thrust it's producing, how much fuel it's burning. This time instead, you've got a driver in there that just keeps the pedal to the metal and goes as fast as he possibly can, puts as much as he can, and tries to stay on the track. So that's nothing new, except that it's going to be in two dimensions. So the thrust will always be applied in the direction that the car is pointing. All right. Fairly simple, fairly straightforward. I think you can do that. And so after you've done that, since that's the first part, this is going to look something like this. So you're going to have this car, and it's going to accelerate. It's going to get faster and faster, and then it's going to try to turn, and nothing's going to work because you haven't programmed in the friction on the road. Now, there is some friction on the road, right? There is friction on the road just to make it start. So that's the static friction. We've got two other kinds of friction that need to be accounted for to make it turn. Okay, the first kind of friction, actually, you don't need to make it turn, but but that friction will produce maximum velocity, and that type of friction is going to be the rolling friction of the wheel. So the rolling friction of the wheel keeps on going on this thing. That keeps your car slowing down and things like that. On top of that, you're going to have a dynamic friction, and that's from when the wheel is turning, right? When the car is turning, you're going to get some skidding, all right? So when you actually have this worked out, right, when you actually have worked out what's going to happen with the skidding and so forth and so on, your car is going to be able to follow this path. It'll go faster, and it'll go faster, and it'll go faster, and it'll go faster, and then it will screw up and it'll slow down. So that's going to be the second part. So what you're going to have to do with that is you're going to have to apply the friction along the direction of the velocity, right? While you're going to direct the two different components in the direction of the car, right? So you've got things going on in the direction of the car and the direction of the velocity, and you're going to have to worry about projections based on the direction of the car for the different kinds of friction. So this is going to be a pretty fun exercise. I think you're going to like it, and you're going to be really happy with yourself after you're done, and it will help a couple of you in your final projects, I think. At least in the past couple of times it's been useful for the final projects, so I think it will be useful for many of you right now as well. So why don't you go ahead and get ready for this, think about what you're going to have to do, and then in class we'll actually do it. All right, so thank you very much, and we'll see you in class.